Over the past few weeks, some of the vocabulary and things that we've studied in science have revolved around biotic and abiotic factors in ecosystems. We've studied scavengers, decomposers, producers, the three types of consumers, and we all just finished up a test on a majority of that. We looked at food chains and food webs. We looked at how energy moves through a food chain. And throughout all of that, what we were really learning was the basis of what makes each biome very unique. And now that we have studied all that and we have an understanding of all that, it's time for us to dive into very specific biomes. And before we can do that, we really need to talk about the two types of biomes that we're going to study, because then that puts us into very specific places. And the two types of biomes that we're going to study are aquatic biomes and terrestrial biomes. If we take a look at our vocabulary, wow, that is not remotely lined up, is it? Let me get that lined up for us here. Yeah, that's a little better. No, that is not even better at all. Hang on. It's a little better now. As we start to look through ecosystems number 4, the vocabulary for this week, we're going to start to see some very specific biomes in here. Tundra, tropical, but this word here is one that's very important. Terrestrial. Terrestrial. Anytime we see the word terrestrial, we need to understand that it means related to land biomes. How do we know that? Because the very beginning of this terrestrial starts with terra, which comes from the Latin or the Greek word meaning land. We also have some other very important ecosystems, some biomes listed in here, and we have some words that we're going to come across like pollutants, freshwater, saltwater. But another very important word that we're going to come across is aquatic. Aquatic biomes are any of the biomes that have to do with water. And that is our first topic of study for this first part of the week is aquatic biomes. And the big, most important thing is we're going to learn the abiotic factors in an aquatic biome, as well as the biotic factors, and how the combination of those two make each biome very unique. So as we dive into aquatic biomes, we need to know that they have to deal with water biomes. Aquatic biomes are dealing with water-related biomes. There's a fantastic video in Study Jams I highly recommend that you watch. We'll probably watch some of that in class each day this week. So my Monday, Tuesday kids will watch it with me, and my Thursday, Friday kids will watch it with me. But it's not a bad thing to get a head start on that, so you have a little bit of an understanding of that. When we're looking at aquatic biomes, we need to understand that it starts with this word aqua, which is really close to Latin for agua, which means water. So if you speak Spanish, agua means water. It comes from the same source, Latin or Greek. The prefix means water. So when I see anything that has this aqua in front of it, and if you happen to forget that, then just think about Aquaman. Aquaman lives in the water, and that's why he has that name, Aquaman. Aquatic biomes. Here's some of the aquatic biomes that we could be studying. Lakes and ponds, rivers and streams, estuaries. That is one that if you are taking notes, when we are taking our notes on estuaries, I would put a big giant star beside that and I would highlight the notes. Estuaries shows up on every test, every benchmark, every quiz, every EOG, and there's always at least 4 to 5 questions related to estuaries on there. Coral reefs. Now we've moved from, and we'll get into this as we start looking in here, I can drink the water in a lake and pond. I can drink the water from a river and stream. I get into coral reefs, I'm getting into salt water. Estuaries is a very specific type of water. We'll get into that. And then open oceans. And there's even more aquatic biomes that we're going to study as we move through the week. As we start to dig into aquatic biomes, we're going to divide it up into basically a couple of ways to look at it. First, we're going to look at marine biomes. Marine biomes are the largest biomes on Earth, and the reason why is because it refers to the oceans, and the oceans cover a huge portion of the Earth's surface. Depending on the source that you look at, the numbers do vary, but I would say that oceans cover somewhere between 70 and 75% of the Earth's surface. And it's safe to round that 70 up to 75. And let's just say that the oceans cover 3/4 of the Earth's surface. An even more staggering number than that, 97, that's rounding up a little bit, but 97% of the water on Earth is ocean water. Now, what do we all know about ocean water? If you've ever been to the ocean and you're out in the ocean playing and a big giant wave knocks you over, you go underwater and you get a big mouthful of ocean water, it isn't very refreshing because ocean water is very salty. We would say that the marine biome has salt water. Now, how do we describe salt water? Now, this is probably the easiest definition of the week. You should not miss this. No one should miss this on the quiz. Shocker, salt water has salt in it. I know that's an amazing thing to think about, but no, it is very heavy in the amount of salt that is in the oceans. So again, we're going to see the word marine pop up very often. Marine, I do not want to see anyone in our Google Sheets this week giving me information about that branch of the armed forces. Okay, marine, when we're talking ecosystem, has to do with the oceans. And you cannot get that mixed up. We need to make sure that we're focusing on ecosystems. Last week, people were giving me some definitions of community that, while they weren't necessarily incorrect definitions, they were incorrect because they did not fit what we were talking about in science. So again, when we're talking about marine, we're talking about the largest biome, ocean. So a fact that I would write down about marine is it's the largest biome. A fact that I would write down about the marine that has to do with an abiotic factor, and that's the water is very salty. Now, what about sunlight? Well, the sunlight varies in different oceans. It really depends on what ocean you're talking about and what time of the year. Temperatures, they vary. They change from season to season and from location to location. The closer we are to the equator, the warmer the ocean is going to be. The further away we get from the equator, the colder the water is going to be. Soil, well, there's not a lot of soil to talk about in the ocean. Unless you want to talk about the ocean floor, then it's very sandy. So when we're talking about the marine biome and we're focusing on the abiotic factors, we need to think about sun, soil, temperature, and water. The biggest thing is it's salt water. Now, another thing that we need to think about are the types of biotic factors. Are we going to find giraffes in a marine biome? No. Could we find sharks and clownfish and sea anemones and moray eels and remoras and sea turtles? Absolutely. Those are the types of abiotic factors that would live in a marine ecosystem. They have, vocabulary word from last week, adapted to live in salt water. And that's very important. You can't take a catfish or a bass or a carp and throw it in the ocean and expect it to live. They have not adapted to salt water. Marine biomes have the most biodiversity. Now we got to think about this word here, biodiversity. Number one, we know that bio means life. So we remember studying bio, and meaning that means life. Now, diversity. Diversity means to have a variety of something. More than one thing, you have a variety. So if you have a variety of life, meaning marine biomes have the most biodiversity, meaning they have the most types of living things in the oceans. They have more types of plants and animals combined than anywhere else on the earth. When we're talking about the ocean biomes, we're talking about all the five major oceans: Pacific, Indian, Southern, Atlantic, and Arctic. These are divided into different regions. We have shallow, we have deep. That's fine. You don't have to remember all of that. You really need to understand that oceans are saltwater, and you need to be able to list off a variety of animals that live there. Dolphins, sharks, jellyfish, starfish, seahorses, sea anemones, eels, whatever it happens to be, you need to be able to differentiate between animals that do live in the ocean and the ones that don't, because there will be questions that revolve around that. As we mentioned, not only are the oceans the biggest biome, and it covers roughly 70 to 75% of the earth, it is extremely salty. There's about 1 cup of salt per gallon in the ocean, and that's a lot of salt. There are over 1 million species of plants and animals discovered in the oceans, and scientists think there may be 9 million more we haven't even discovered yet. One reason the ocean is very important is because of all the algae. Now, if we remember back to what we just studied, algae is a plant. Plants are extremely important. Not only are they the beginning of the food chain because they make energy from the sun, plants also, in the process of photosynthesis, they take in carbon dioxide and they release something that all animals need: oxygen. If it weren't for all of the algae in the oceans, we would not be able to breathe. It is vital that those algae are releasing the oxygen into the atmosphere. It's vital for the oceans to survive that the algae are there to begin the food chain for many, many animals. So algae is an extremely important thing in our marine biome, or the oceans. We have now hit probably one of my most favorite things to teach at the beginning of the year, and it mainly has to do with the video that I think is right after this slide. But we want to talk a little bit about kelp. One type of marine algae is kelp. Now, a lot of people usually think, oh, Mr. Bull, it's algae. That's that green stuff that I see on top of ponds around the house, and you are correct. Another type is kelp. Kelp is extremely important. Not only does it provide shelter, a habitat for a lot of sea creatures, it provides food for animals that live in the marine biome. Kelp is used by humans for many things, including toothpaste and ice cream. Hopefully that doesn't make you stop brushing your teeth and stop eating sweets, because it's a good thing. Kelp is a buffer, which that means it helps to absorb the energy from waves before they hit the shoreline, especially in California. What that does is they take a lot of the energy from the wave, and it stops the waves from eroding the coast of California. And if you didn't have the kelp there, it would erode the coast extremely quickly. Another important marine plant is phytoplankton. Phytoplankton are teeny tiny plants that serve as food for many of the ocean creatures, from small fish, and that would seem normal, right? A teeny tiny plant, teeny tiny fish, not a problem. But whales also eat phytoplankton. These phytoplankton are just as important as algae because scientists have estimated that phytoplankton provide Earth with half of its oxygen. I just want you to imagine that half of the oxygen on Earth, according to scientists, has been provided by phytoplankton. So we can tell that they are extremely, extremely important. As we've mentioned, the oceans are very biodiverse. When you're talking about biotic examples, you could use some from this slide: mollusks, fish, whales, crustaceans, bacteria, fungi, sea anemones, and many, many other creatures live there. And they have all adapted to the fact that the ocean is salty and it's often cold, and those creatures have adapted to that. Places are more salty, and what would happen is if there's more water evaporating or sea ice is forming, it causes it to be more salty. And if it's less salty, you have fresh water running into the area, or possibly sea ice melting, or even rain. it for today. Smash that like button and subscribe.